Hello girls, today we are going to continue lesson 1, physical properties of the electric current. Remember that we already discussed the uses of electricity, the structure of the atom, and the definition of the electric current. We also started talking about the physical properties of the electric current, and we defined the current intensity of the electric current. Today we are going to discuss the second property of the electric current, which is the potential difference. Before we start, we must know what is the meaning of the electric potential of a conductor. The electric potential of a conductor is the state of an electric conductor that shows the transfer of electricity from or to it when it is connected to other conductor. In other words, the electric potential of a conductor is how much energy the conductor has compared to another conductor which is connected to it. To show what the potential difference means and how the electricity is transferred through conductors, let's understand the following example. If you have two objects, a hot object A and a cold object B, then connect the two objects with a metal bar. You will observe that the temperature of A decreases and the temperature of B increases until their temperature become equal. This is because the heat moves from the hot object to the cold object. This movement doesn't depend on the size of the two objects, but it depends on the difference in their temperatures. Thus, temperature difference determines the movement of heat energy to and from an object. Similarly, in electricity, if two charged conductors touch or are connected with a wire and one of them, which is conductor A, has electric potential higher than the other conductor, electric energy in the form of the electric current, of course, will flow from A to B until their electric potential becomes equal. Also, the transfer of charge doesn't depend on their amount, but it depends on their difference in their potential. From the previous explanation, the potential difference between two poles of a conductor can be defined as it's the value of work done to transfer a quantity of electricity of 1 joule between the two poles of this conductor. What does this mean? To make it easy for you, here is a simple electric circuit which contains battery or a cell and a lamp and electric wires. And this is the column or the electric charge that pass through the wires. Okay? The electrons go around the circuit and get the energy from the cell and give this energy to the lamp so it changes to light energy. And then the electrons return back to the cell out of energy. So it goes back to the cell to get another energy and so on. If we measure the difference in the energies before the cell and after the cell, we will get the amount of energy given to each column of charge, and this is the definition of the volt. The voltage is how many joules of energy we give to each column. we use the voltmeter to measure the potential difference around the cell. And as we can see, the voltmeter is connected in parallel with the electric circuit. Also, if we measure the difference of energy before and after the lamp, we will measure how many joules of energy is lost by each column of electrons as it passes through the lamp. And also, if we want to do this, we must use the voltmeter to measure the potential difference around the lamp, and it also must be connected in parallel with the electric circuit. From the previous explanation, now we can get our second rule in our lesson, which says that the potential difference equals work in joules over the quantity in coulomb. Again, rule 2. Potential difference in volt equal work done in joules over the quantity of electricity in coulomb. It means that 1 volt equals 1 joule over 1 coulomb. And from here we must know the definition of volt. It is the potential difference between the two poles of a conductor, or in another word, it is doing a work of 1 joule to transfer 1 coulomb through the electric circuit. And of course, we already know the voltmeter. The voltmeter is a device used to measure the potential difference between the two poles of a conductor, and it must be connected in parallel with the electric circuit. And now here is an example for you to solve depending on our second rule. V equals W over Q. Thank you so much for listening, and wait for the next part of the lesson. Thank you.